1,000 kilogram car stands from rest and accelerates uniformly to 90.7 meters per second in 11 seconds. Assume that air resistance remains constant at 400 newtons during this time. A. Find the average power developed by the engine. And B. Find the instantaneous power output of the engine when time is 11 seconds used for the car to accelerating. Well, the data is the mass, that is 1,000 kilograms. The initial velocity is 0 meters over seconds. The final velocity, that is 19.7 meters over seconds. The time, they give us 11 seconds. And they give us the air force, that is 400 newtons. We want to find out the motor force. And here's a sketch. You know, this is a car. And we want to know the motor force that goes to the right. And we have the air force that is 400 newtons that goes to the left.
The sum of all forces is equal to the mass of that acceleration, and we want to get first. So our forces is force of the motor minus force of the air, because it's resistance. It's equal to mass times acceleration. So we clear, and we have force of the motor is equal to mass times acceleration plus force of the air. And we want to get the acceleration. So acceleration is equal to velocity final minus velocity initial over time. So we have the velocity initial minus 0 over 11 seconds. Our result will be 1.79 meters per second squared, and this is the acceleration. So we have the acceleration here, and our result will be force of the motor is equal to mass times acceleration plus the force of the air. That will be 2,190 newtons.
So after we have the more force, we have to get the work. So like the formula is power equals work over time. So we have to get the work first. So the formula is work equals force times distance times cosine. So we don't have distance, so we use this formula. There is x equal initial velocity times time plus acceleration times square over 2. So substituted is 1.79 times 11 to the square over 2, and we have 108.30 meters. So after that we have to multiply 2,190 newtons times 108.3 meters times cosine, and cosine is 0. So the result will be work equals 237,177 joules.
So we have the work. So we can use the formula power equals work over time. So substituted is 237,177 joules over 11 seconds, and the result is this: power is equal to 21,561.454 watts. That will be the answer for our A question.
And to get the instantaneous power when the car is at 11 seconds, we have to use this formula. Power equals force times velocity times cosine. So substituted will be power equals 2,190 newtons times 90.7 meters over seconds times cosine, that is 0. So to get to the final answer, it will be power equal 43,143 watts, and that will be the final answer.
So in conclusion, the average power will be 21,561.54 watts, and the instantaneous power at 11 seconds will be 43,143 watts.